Thanks, Amanda, for the nice introduction. Welcome, everyone. Pleasure to talk here. I will, as said, I'm a research lead, so I'm a machine learning researcher at Zalando in the research lab there. And I will give you a quick overview of a few of our developments in the recent times. So let me quickly give a quick overview for those who don't know, which is probably no one. Over Zalando, we were founded exactly 10 years ago, and by now we are pretty big. Given that it's only 10 years ago, we're one of the fastest growing companies in Europe, alongside Spotify and the like. 4.5 billion euros revenue 2017. The main message here and relevance for the talk is we are an e-commerce company, and with that we have a lot of data because we have a lot of customers, we have a lot of customer interactions, 23 million active customers, and also many employees in many different countries all over Europe. So that means to leverage that data that all these interactions with the customers produce, we also have a lot of researchers and machine learning researchers in particular, with more than 100 in the company. And I'm working in Zalando Research, which is more the academic side of it. And we are more horizontally throughout the company. And we are split in 4 teams. We are driven in each team more by the methods than by the product, and by a strategic vision going alongside with it. And then on this way, we search impact in the company. And I will talk about a few things that have come up. So the 4 teams are, first team is more about image analysis. The second team is kind of the opposite, image generation and data generation. The third is about control and interacting with the environment, which is actually a pretty big thing for the business. And the final one is natural language, because it's the most natural way how you interact with computers and, well, how humans also interact with each other. Okay, so getting a bit more into the topic now, machine learning in fashion. So to open the box of this whole AI thing, and this slide will open it a bit and show you that it's actually not that magic, what's actually happening. Because if you look at this standard example, everybody who I don't know, maybe some of you already played around a bit with TensorFlow or did some image classification. The standard data set you get is this MNIST data set on the left here, where you're supposed to classify what this digit means. So the upper left one would be a 5, for example. And the computer is supposed to learn that this is a 5. And then you throw lots of this data to the computer, and it's supposed to learn because it has labeled data set, it sees images, and it knows it's a 5, it sees a 0, it has 0, and so forth. And actually, we thought last year that this is a bit boring. And as it turns out, it was boring for the whole academic world as well. So we published the fashion MNIST data sets, which is actually pictures from our catalog, and it was actually quite successful. So many people are using it now to benchmark their methods with these fashion articles. And here it's completely analog. That's why it had such a big impact, because it's the same data format. I mean, the floral patterns are a bit fade, but otherwise it's pretty nice. So, and opening the box now. So most of the things that are actually used in business is actually what's in the literature would be called regression or classification. And for these things, in particular in the image space, the best solutions are deep learning. And for deep learning, you actually have to mainly define 2 things. You have to define the architecture, that is how you build your network, how you connect your neurons, your artificial brain cells to produce an output from the input. And you have to define a loss function. And the loss function is basically how you measure how good your system is. So from a business perspective, it's the same as a KPI of your team or something, right? It's exactly the same. Only here, we are dealing with computers, so you have to be very precise what you actually want the computer to do, because it will do this, right? It will optimize exactly for this, right? And when you have defined this, then you just do mathematical optimization, and you are done. And basically then your computer can tell you new numbers, new fashion articles, what it is. That's all that happens actually. So going a bit more real world and a bit away from this toy example, what we have been using this for is, for example, the size recommendation So here, the architecture is kind of a two-way architecture, a Siamese-like architecture is the technical term. We have one part of the architecture encoding the customer and the other part of the architecture encoding the article. And then in deep learning, the nice thing is because it's end-to-end trained, everything is learned, you can connect any data you want. On the customer side, you can add age, whatever. On the article side, you put measurements, materials, anything. And then the loss function in this case is a bit complex because you don't only want to reduce returns, which is a big pain point for Zalando because we send out stuff and take it back for free. So we want to minimize this from a business perspective, and also customers, of course, want to minimize this because it's very inconvenient. So one part of the loss function is you want this predict this return probability, and the other one is you also want to predict what a customer would buy, which size, right? And combining this, then you come up with a loss function. It's a bit mathematical, and then you can predict which size would best suit a customer, given enough data. So to show that this framework is very general, here a slightly more complex example, which is also tailored toward the fashion industry and in particular in our search engine. So now instead of 2 columns, we have 3 because we have natural language. If you search for something on our website and you want the product to pop up, you can also learn this with a very similar architecture, right? You have now encoding of an image of the article, basically, which is encoded through the image and the attributes of the article. And on the other side, you have an encoding of your typing of what the people write. And then the loss function is basically matching how this matches together, right? And then you can build an end-to-end search without all this engineering that comes along with it. So most of business work, as said, is basically falling in this category, but very exciting, I think, for the fashion industry is more recent developments. And this is, as mentioned already in the introduction, is generative adversarial nets. And the key insight Ian Goodfellow had in 2014 here is that instead of handcrafting the loss, and I think you have heard from my earlier point on sizing that this sometimes can be tricky to do. He just proposed, well, just learn the loss and just learn 2 neural networks alongside, and then they play against each other or with each other in a sense, right? And then this allows creation of new patterns. So this pattern here on the right is completely made up by a computer. It's not real, although locally it looks everywhere like snakeskin. So what can you do with this? You can, for example, that's a paper we had last year, you can try what a computer thinks a new article would look like on a person, right? So all the data that we have, and we have a lot of this data in our catalog, is we have articles of people, images of people wearing articles, and the articles going alongside with it, right? And then we also have articles, and we would like to know how the different article would look on a person, right? And instead of now going there and engineering a lot and squeezing and 3D inferring and all that stuff, we just say, no, let's design a machine learning method that just looks at the data and tries to fill in this hole, right? And making it look plausible to the machine. So there's nothing specific to fashion here from the algorithmic side. The only thing that's specific is the setup of the problem, right? And then as you see in the results, the generated column is what the computer thinks should fit in here. And this is pretty amazing. Although, of course, it's not yet photorealistic, it's just data-driven. It's really what the computer came up with. And the final thing is, I think, maybe most amazing, these dresses here are completely made up by a computer. They don't exist, they never existed, and they're produced in a very same way, right? The computer just looked at many, many dresses, and then you just tell the computer afterwards, after it is trained, okay, I want a green dress, I want this in this pattern, in this case, no pattern. I want kind of this shape in the bottom, and then the computer comes up with possible dresses that fit this shape, or you constrain it less, and then you can explore this space. Yeah. Then, so conclusion maybe from this talk is, I think standard business machine learning methodologies you can leverage already for many applications, like size recommendation in our e-commerce or end-to-end search. But in the future, I think we will see a lot more. And in a sense, what I have shown you previously, I think it's creative to some degree, but only in the sense that it can interpolate the data, and not in the sense many of you probably think about creativity. Okay, thanks.